All right, so hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. So here's my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for the last 11 years. So we were doing application of derivative, and in this session I'll continue that. Basically in this session we'll do some practice problems. We have already finished tangents, normal, subtangent, length of normal, and length of subnormal, angle of intersection of two curves, and shortest distance between two curves. All right, so now we will do some questions based on these topics today, practice questions. But before we begin, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and once you get the subscription, you you can get two types of subscriptions you can buy on Unacademy. One is Plus subscription, other is Iconic subscription. So in Plus subscription, you get unlimited access to all the educators who are teaching for IIT-JEE. You can watch their live sessions as well as recorded sessions also. And all live tests and quizzes will also be accessible to you. So all these courses are well structured, and unlimited access you get once you are subscribed for IIT-JEE. All right. Plus, these are the subscription charges. 1 minute. So these are the subscription charges. Now 38,500 for 2 years of 12 months, and 24 months it is 56,000. Okay, and you get 10% discount in that also. So use this code JEET1 and get 10% discount. Now second is Iconic subscription. So in Iconic subscription you get a personal coach. So get one so get one-on-one guidance from top exam experts as your personal coach to align your preparation. I mean, you get a personal coach who will guide you throughout your preparation for IIT-JEE. Your test analysis will also be done in a personalized manner. Your study planner will be customized, okay? And you will be given feedback to improve your time management and exam approach. So all these things will be in addition to all the benefits you are getting in Plus. That unlimited access. All right, so this is Iconic subscription, and these are the subscription charges: 56,000 for 1 year and 86,000 for 2 years, and you'll get 10% discount in these two packages also. So this is what you get. Yeah, this is Unacademy's learning app. Okay, you can download it from Play Store. Now let's do some questions, as I was telling you. All right. So if 3x plus 2y is equal to 1 is a tangent to excuse me at x is equal to 1 by 2, and if p is equal to limit x approaching to 0, x into x minus 1 divided by f e raised to 2x divided by 2 minus f of e raised to minus 2x divided by 2. Then we need to find sigma of p raised to r from 1 to infinity. So this is the first question, okay? Try this one. P is equal to 1 by 3. Cooper is back. P is equal to not 1 by 3, but you're close. P, okay, you are getting P is equal to 1 by 3. Wait a minute. Yeah, P is equal to 1 by 3. Good. That's right. That's right. What's your name, beta? So if you find the limit of this, this line is tangent to this curve. That means we can write f dash of 1 by 2. So f dash of 1 by 2 is slope of tangent. Slope of tangent is minus 3 by 2. Good. And to find the limit, it is 0 by 0 form. So you can differentiate it. So it is going to be 2x. Abhinav. All right, Abhinav. So it is 2x minus 1. 2x minus 1 divided by, if you differentiate it, it is going to be f dash of e raised to 2x by 2 and then e raised to x. minus f dash of e raised to minus 2x divided by this will become a differentiation of e raised to minus 2x as e raised to minus 2x into minus 2 by 2, so this will become plus 1. Now x is approaching to 0, so now it is not 0 by 0 form. It's alright. So now let's put the value 0 put kar denge. So this is going to be minus 1 divided by, if you put 0 in this, it is going to be e raised f dash of 1 by 2, yeah, plus f dash of 1 by 2. Now put the value of f dash 1 by 2, so minus 3 by 2 minus 3 by 2 is minus 3, so that will become 1 by 3. That's right, absolutely correct. And what is the answer? Now it's a GP, right? So 1 by 3 sigma of p raised to r is an infinite GP, 1 by 3 square, 1 by 3 cube, right, and so on. So that is 1 by 3 upon 1 minus 1 by 3, so it is going to be 1 by 2. All right. True. Find in the next question is, if x raised to 5 by 3 minus 5x raised to 2 by 3 is equal to k has exactly one solution, then k lies in, options are minus infinity to plus infinity, option B minus infinity to 0, option C 3 to infinity, and option D is 0 to infinity. All right. Try it. So basically you need to draw the graph of this. Y is equal to x raised to 5 by 3 minus 5x raised to 2 by 3, right? Are you doing it? You are getting any answer? Okay, so if you get the answer, then write in the comment box. Meanwhile, I'm solving it. Okay. So I want to see the graph. Domain of this function is R. Okay, x belongs to R. So all right. So if you differentiate it, he'll get to know where this function is increasing and where it is decreasing. So uh, minus in at x is okay. Let's differentiate it. So it is 5 by 3 x raised to 5 by 3 minus 1. So 5 by 3 minus 1 is basically 2 by 3, and then minus 5 into 2 by 3 x raised to 2 by if you differentiate x raised to 2 by 3, you'll get 1 upon x raised to 1 by 3. And after taking LCM, you'll get basically 5 by 3 is common. You'll get x minus 2 divided by x raised to 1 by 3. Okay, and if you see, plot the critical points, it is 0 and 2 plus minus plus. Okay, so it is increasing, decreasing, increasing, is this type of graph. So for x approaching to minus infinity, you can see this y is approaching to minus infinity because this will approach to minus infinity, and this is magnitude y is greater. And for x approaching to plus infinity, this leading term, the highest, the power term which has higher power, is going to plus infinity. So for y will also approach to plus infinity. So graph is coming from minus infinity, is increasing up to 0. Then from 0 it is going to decrease, and after 2 it is again going to increase. I'm just plotting the rough sketch. Okay, it might not be differentiable at these points. At 0 it is not differentiable, you can see, right? At 0 it is not differentiable. So this point there will be some corner, sharp corner or something. Okay, so I'm not interested in that exact graph. I just want to see that what should be. Okay, so what is the value of 0? At 0 you can see y is 0. Okay, so graph is like this. Okay, like this. Now you are equating it with k. So if y is equal to k, if I plot this line, y is equal to k line, and y is equal to k line cuts, k is positive, then it will cut only at one point. Graph mein, okay. If k is less than 0 and more than this number you can calculate, because you know this point is 2. All right, so you can calculate this number. Then it will have 3 solutions, and you actually will have to calculate this number. Okay, so from this number, whatever this number is, you can put 2 in this, and you will get, it will be some irrational number. So only one answer you can see will match 0 to infinity, although you are getting these values also. Okay, because if you draw a line here, then also you'll get only one solution, but that is not given in the answer. You can't say minus infinity to 0 will be wrong, because these values are not in the solution. 3 to infinity, or you can also say, right, if k lies in 3 to infinity. So this, in multiple correct, you can say 3 to infinity is also correct. Okay, so if k lies in 3 to infinity, then also it will have only one solution. Minus infinity to plus infinity is wrong. Okay. Okay, so basically we will learn graph. This is a practice session I'm taking. I'll continue theory of AOD. So in theory of AOD, I will tell you how to plot the graphs. Abhinav. Okay, I'll tell you the graph properly. Okay, let's see. Y is equal to x raised to 5 by 3 minus 2 times of x raised to it was 2 by 3. So I don't know. सबसे पहले क्या करते हैं कि when x is, see, domain is R, right? Domain is R because this term is defined for all real values and this term is also defined for all real values because you are taking cube root. So cube root is defined for all real values. Okay. The domain is R. That's one thing. Second we see because domain is R, so minus infinity पे graph कहाँ होगा और plus infinity पे कहाँ होगा, we need to know that. So when x approaches to minus infinity, you can see this x raised to 5 by 3, okay, because this power is odd cube, you are putting 5 power and then taking cube root, so negative number will be negative only. So if you put minus infinity, then minus infinity raised to 5 by 3 will be minus infinity only. Although this will become, and this is also minus infinity, you can see 2 by 3. Because of this 2, this will become positive, and because of this minus sign, it will remain. So when x is approaching to minus infinity, this will approach to minus infinity. I hope you will understand this limit, okay? And when x is approaching to plus infinity, then x raised to 5 by 3 minus 2x raised to 2 by 3. This will approach to, now this is plus infinity and this is also plus infinity, but infinity minus infinity will be infinity because this one is larger. Its power is more than the power of second term. So it depends on the power, okay? If power is more, then limit will go towards that side. Like in polynomials, so it is plus infinity, okay? So we have got the graph will come from minus infinity, it will go to plus infinity. Now third step is to differentiate this curve, to know where this function increasing and where this function is decreasing, okay? So to know those intervals, you need to differentiate it. So if I differentiate it, it'll get 5 by 3, x raised to 5 by 3 minus 1, that is 2 by 3, minus 4 by 3 x raised to minus 1 by 3, okay? Sorry, wait a minute. Oh, it was 5. This number was 5. This number is 5, so already 5 into 2, okay? 5 into 2. So now you can take 5 by 3 common, and if you take LCM, so this is going to be x minus 2 divided by x raised to 1 by 3, okay? Like this. Now you plot the number line, like wavy curve method. Critical point of this number is 0, and critical point of numerator is 2. And when x is more than 2, this expression will be positive. Then when you cross 2, then numerator will change its sign, so overall sign will change. And when you cross 0, so denominator will change its sign, so overall sign will change. Now this is the sign of y dash. So you can see y dash is positive in minus infinity to 0. 0 to 2 it is decreasing, and 2 to infinity it is increasing, okay? So graph will come from minus infinity. It will keep increasing, okay? Now how is this graph increasing? That is we are not concerned about. For that you need to double differentiate it, okay? So graph might come like this, or graph might come like this also. Concave up and concave down, you'll have to figure out using differentiability, okay? So we are not checking that because the number of solution that is not required. So it is increasing up to 0. Then after 0 it is decreasing up to 2, okay? So this point is this is actually x-axis. So this point is 0 and this point is 2. So it is decreasing up to 2, and after 2 it is again increasing, okay? It's like this. This is a rough sketch because we are not checking the concavity. So it might look like this also. It might look like this also. Actually it might be like this because it is not differentiable at 0, so there will be a corner at 0, okay? Got it? Okay, all right. The next question is this. Which of the following functions, which of the following curves are orthogonal? First option is x square raised to 21 plus y square raised to 17 is equal to 1, and x square by 3 minus y square by 1 is equal to 1. Second is x square by 47 plus y square by 4 is equal to 1, and x square by 21 plus y square by 23 is equal to 1. Third is x square upon 49 plus y square upon 4 is equal to 1, and x square by 23 minus y square by 22 is equal to 1. Fourth is this: x square by 29 plus y square by 9 is equal to 1, and x square by 42 plus y square by 30 is equal to 1. So you need to figure out which of the following pair will represent orthogonal curves. Okay, one or more than one answers might be correct. Okay, basically orthogonal की condition होती है m1 m2 dy by dx of first and dy by dx of second. That means m1 m2 should be -1, but in this case these are conics, parabola and ellipse. Okay, hyperbola, ellipse and hyperbola. So in case of ellipse and hyperbola, I'll tell you one condition. Okay, so the condition to make this ellipse and hyperbola orthogonal, okay, so if x square upon a square plus y square upon b square is equal to 1 is an ellipse, of course, then hyperbola, okay, or in fact, okay, hyperbola orthogonal to it is given by x square upon a square minus lambda. You will subtract lambda, some constant, from a square, plus y square upon b square minus lambda. You will subtract the same constant from b square also, and in this way Where's this lambda up now? This is a hyperbola. It should be a hyperbola, because if lambda is less than a square and b square, then it will remain an ellipse. It will remain an ellipse, and that ellipse will be basically confocal with the first ellipse, but it won't cut it. So that won't be orthogonal to it. But if lambda, let's say a is more than b, okay? So if lambda is more than b square and less than a square, then actually this number will be negative, b square minus lambda. And you can write this equation as x square upon a square minus lambda minus y square upon lambda minus b square, okay, is equal to 1. This is a hyperbola. This hyperbola will be orthogonal to the given one. Okay, this hyperbola will be orthogonal to the given curve. Directly you can do. We can take any value of lambda. Like if you have written x square upon 25 plus y square upon say 16 or say 9, okay, or say 9 is equal to 1. Now say you can subtract any number more than 9 and less than 25 from these two. So let's say we are subtracting say 13. Yeah, 13. Let's say it's a concept of orthogonal curves in ellipse and hyperbola. You can study, it's given in SL only also. It's a very beautiful concept. I have covered in some of the topics. This concept I have covered in some of my lecture. Okay, so if you subtract say 12, so you'll get this hyperbola x square upon 13 minus y square upon, if you subtract 12 it will be 3, right, is equal to 1. So this hyperbola, this is a hyperbola and this is an ellipse, and these two are basically confocal. They have same focus. They will have same focus. You can find the focal coordinates of focus of this hyperbola and this ellipse. They will be same. They are confocal curves and they will cut each other orthogonally. This is the hyperbola and this is the ellipse. They'll cut each other orthogonally. They are confocal and they will cut each other. But if lambda is, if you are taking lambda, if lambda, you can take any value from 0 to of course less than b square, otherwise this won't represent anything. Then if it remains ellipse, then that ellipse will be something like this. So these two ellipses won't cut each other, but they will be confocal. But as soon as it becomes a hyperbola, when will it become hyperbola? When lambda is greater than b square and less than, of course, a square. Then this will become a hyperbola and it will start cutting the given ellipse. So it will also be confocal, but it will cut orthogonally to the given. So now you can guess, okay? Now you need to see in which of the option you have subtracted the same constant from both the values of a square and b square. So if you know this concept, you can answer this easily, all right? Check it. Everybody, are you getting the options? Are you able to figure out the options? So in this, you can say if you subtract minus 18 and minus 18, you will get this, right? So this is the correct option. Second, both are ellipses, so they won't cut each other, okay? Although in third, 49 and 4. So 49 to 23, how much you have subtracted? You have subtracted 26, yeah, 26. If you subtract 26 from, yeah, so this is 26 minus 26, okay, you'll get this. This is also correct. And this again two ellipses. This is the answer, okay? So I hope you have got it, huh? Yes, 1 and 3 are correct. Good. Okay, so now we'll continue theory in our next session, okay? Thanks for joining. I hope you have enjoyed this session. All right, then see you again in next session. Chalo, take care. Bye-bye. All right, so you need I'm explaining sets. Are you Subhash, are you able to see this? All right, so I'll explain sets. First of all, subset, okay? You have some you sent me some doubts, okay? So I'll explain those doubts. X is a subset of Y, okay? You have this symbol. This symbol is for equality, okay? This represents just every element of set X. Every element of set X belongs to the set Y. All right. Every element of set X belongs to the set Y. But converse of that is not true. That means every element of Y not necessarily belongs to X. Okay. But if you write this statement that X is a subset of Y and Y is a subset of X, now you are saying that X, every element of X belongs to Y and every element of Y belongs to X. Y is a subset of X. Then that means this implies that X is equal to Y. And X and Y must be equal. Are you understanding this? If ऐसा बोले कि सारे एलिमेंट्स X के Y में हैं and Y के सारे एलिमेंट्स X में हैं, then this is only possible when X is equal to Y, right? So if you put these two conditions simultaneously, that implies that X is equal to Y. So this was the meaning. Okay. First thing. Second, about proper subset. What is proper subset? This symbol you just call subset. Okay. Now proper means proper subset. Although it was written there, you just remove this equality sign. Okay. So you just put this symbol alone X is a proper subset of Y. That means every element of X belongs to Y, but X is not equal to Y. That means all elements of Y will not be in X. X and Y will not be equal. Otherwise, everything is same as the before. Same as before. Like if Y has 10 elements, then X can have 9 elements, X can have 8 elements of Y, X can have 7 elements of Y, X can have 0 elements of Y. 0 means no element. But X cannot have all the elements of Y. X cannot be equal to Y. And another way of writing this is, you can write in this way also: X belongs to Y, X is a subset of Y, and not equal to. Okay, you cross this equality sign में से not लगा देता है. So this also represents the same thing. X is not equal to Y. So this is also for proper subset. Proper subset means it is not equal to Y. All right. I hope this is clear. I'll explain a few more things to you. Power set. Do you understand power set? What is power set? See, phi is a null set. Okay, phi is null set, empty set. So if you have say where y is 1, 2, 3, 4, then how many subsets you can write? How many subsets of y? Then subsets of y are basically, one is phi, that means you have selected no elements from y. So phi is always a subset of every set. Then you have subsets of one element. So one element, now one element you can take 1. So there is one element subset. You can take 2. So there is also one element. Singleton also you call. One element wale subset ko you call singleton set. 3, or you can take 4. So you can make 4 singleton subsets of Y. Then you can make subsets having 2 elements, 1 and 2. Okay. And then 1 and 3, and then 2 and 3, and then 2 and 4, right? So these are subsets having exactly 2 elements, right? Now you can make some more subsets. 1, 2, 1, 3, and 1, 4 was remaining. So basically 6 subsets will be there having exactly 2 elements: 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, and then 3, 4. In this way you can count it: 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, and then 3, 4. In this way you can count it. Then you have subset having 3 elements, right? So 3 elements will be 1, 2, 3, this set, then 1, 2, 4, right? Then you have 2, 3, 4, right? 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 4, then 1, 3, 4 also. So four subsets you'll get. Okay, these are 4 subsets having exactly 3 elements. Now you have finally this Y, all subset having all the elements. That means Y only. So 1, 2, 3, 4. So total how many subsets you have got? Now you can count it. Total subsets. This is the formula for total subsets. Total subsets of 2 raised to 5. Total subsets of Y which has n elements is 2 raised to n. Okay, so it is 2 raised to 4. 2 raised to 4 is 16. So you can count these 16 subsets. And set of all these subsets. See, I am putting these brackets, curly brackets. So now I am making a set which contains all these subsets. That is called power set. Okay, that is called power set. So this is power set of Y, which has 2 raised to 4 elements. This is power set. I think you have got. I saw power set also. Do you have any other doubt? Let me know. Any other doubt? A continuous set is called interval. Like real numbers are set of continuous numbers, right? And natural numbers are not continuous. One के बाद सीधे two आ गया, right? 1 2 3. So you write discontinuous sets को, I mean discrete elements को तुम comma लगा के लिखता है. And if it is a continuous set like 1 to 2, you need to write all the numbers, then you write in brackets. So this is a number line, okay? So in this number line you have 1 2 3 4, say these natural numbers. So natural numbers ko you can write 1 2 3 4 and so on, okay, like this. But it has infinite number of elements, so ऐसे छोड़ देंगे ऐसे. This is set of natural numbers. But set of real numbers you write minus infinity to plus infinity, curly brackets. See, if I need to write this set which has all the real numbers between 1 to 2 but not 1 and 2, okay, 1 and 2 are not included, then what is the way to write it? This is 1 comma 2, we write the end points, and circular brackets means end points are not included, okay. So this set which you call interval also, this interval contains all the numbers between 1 to 2, right? All the numbers, it has infinite numbers, right? Because between 1 to 2 you can see infinite numbers will be there. But if you need to include 1 and 2 both, then you put these brackets, square brackets, okay. If you put square brackets and write the end points separated by comma, now this will represent an interval in which all the numbers between 1 and 2 are included, including 1 and 2, okay. Suppose you want to include 1 but you want to exclude 2. One end point you want to include and another end point you want to exclude, then it will be represented by 1 is square, 1 with square brackets and 2 with circular bracket. So these intervals are also sets, but continuous set. I don't know if it is useful, but yes, certainly later it will be useful. Any other doubt? Write in the, let me know fast. Okay, I'll give you one more formula and then I'll end. Subsets having no, this is not used for both the cases. This is not used for both the cases. If you have crossed it, that means x is not equal to y. This you can use for both the cases. This you can use for both the cases. Even if you know that y is not equal to x, then also you can use this symbol, subset and belongs to and equal to. Even you know that y is not equal to x, you can use this symbol. Even if you know that y is not equal to x, you can use this symbol. But you know that if y is equal to x, then you can't use this symbol, okay? Like natural numbers is a subset of Natural number is a subset of integers. Now we know that natural numbers, set of natural numbers is not equal to set of integers. Then also we can use this symbol, which was used for subset. All right. But you can't write that like this. Natural number is not equal to natural numbers. This is wrong. You know, natural number, these two are equal and you are putting this symbol. This is wrong. I hope it is clear, huh? So shall I end this session then? One to do, one closed and two open. Square brackets means one is closed and two is open. One not one, like x belongs to 1 to 2, that means x can be 1 but x cannot be 2. All right. Okay then. Thank you.